Okay, Deb, then I'm going to turn it over to you.
Okay, cool. Hi, my name's Deb, as she mentioned, and I do a lot of work on algorithmic accountability and particularly looking at auditing and this idea of algorithmic justice. So today I am going to really just go into some of the challenges that we faced while doing this work, and use that to sort of highlight the different mechanisms or approaches that we're trying to use or leverage in order to hold algorithmic systems accountable. And yeah, current affiliations, I'm a Mozilla fellow, and I also work with the Algorithmic Justice League, which was founded by Joy Buolamwini at the MIT Media Lab. So, those that might be paying attention to the news might realize that something is definitely happening. We're seeing a lot of headlines like this of, algorithmic deployments, either resulting in biased or incorrect predictions and affecting people's lives in really drastic ways. So you have, recruiting tools that are biased against women, facial recognition not working on darker skin individuals, delivery apps having discriminatory algorithms, Stanford's vaccine algorithm leaving out frontline workers. There's an increasing number of stories like this that we see in the news. And especially, I would say probably like June last year, we also saw this sort of spike in actual public protests against algorithmic deployments. So here's a picture of a trio of students. I think these students are specifically from Ireland, but there were protests throughout the UK of algorithms that had replaced the typical grading process, human-based grading process for the A-levels exams and other final exams in throughout the UK. And because the kids were not able to sit down for their finals due to COVID, an algorithm adjusted their teacher assigned grades based off of the history of their school or the history of their region in terms of performance on these standardized final exams. And as you can imagine, a lot of the really posh private school kids, the algorithm gave them a boost in their grades, and a lot of lower income students, and particularly students at large public schools, had their grades downgraded significantly from maybe even an A to a C. So these students actually went out to the streets, they protested the use of this algorithm, they protested the lack of an appeals process, and it was really one of at least the first sort of visible protest that I had witnessed on sort of this issue of algorithmic justice. And then, just a couple months later, we had the Stanford hospital that tried to use an algorithm to sort of prioritize different recipients for the vaccine. And they used a bunch of different variables like age, and that biased the algorithm towards senior staff members who were already working from home, and left out a bunch of frontline workers, mostly residents, that were in the hospital every day, and thus, in dire need of vaccine as, sort of first level contact to patients. And that was another sort of really important protest moment that we saw, where these students recognized that they were deprioritized because of this algorithmic judgment, and they actually were able to vocalize that, identify that harm, and then vocalize their resistance to it. So I'm going to start my talk by just giving some important reminders as to the context we're speaking of today. I find that sometimes people have a couple assumptions about this work and the context in which we're doing this work. So I'm just going to put out a couple reminders to just clear the air around those things, those assumptions. And then I'm going to go into what I mean when I say algorithmic accountability. And then I'm going to mention some major challenges that we're facing when we talk about algorithmic accountability, like who are we actually trying to hold responsible, and what are the different mechanisms we have to hold them responsible. And today I'm going to focus on engineering responsibility, since that's the sort of primary current focus of this work. But I'm also going to mention later on other challenges around operator accountability and structural harms. So yeah, for the three important reminders, I think a lot of people come into this conversation with certain assumptions, and I'm just gonna take a minute to just debunk some of that right away. So, I think a lot of people have watched this Netflix documentary, The Social Dilemma. If you haven't, I recommend it. I also recommend The Coded Bias, which is also on Netflix now. But it's this idea that one of the theses of this documentary is that, social media, there's algorithms that manipulate our attention on these social media platforms, and that has very serious consequences. I totally agree with that. But they kind of get into this moral of, please turn your phone off, take time off of social media, and that sort of being presented as one possible solution to address the issues imposed or sort of perpetrated by these algorithms. Though in the context of the work we're doing, it goes beyond these individual dilemmas of, should I stay on my phone or should I turn it off? Often, a lot of the systems we're discussing, you can't just turn off or opt out of. These are systems that are usually imposed and don't always have users that intersect with the affected population. So you might have an algorithm being used by a hospital on patients, by doctors, where the patients are the affected population and the users of the algorithm are, the hospital staff, or the users might be teachers and the affected population are students. And when you have that mismatch, the students don't necessarily have a say in how that algorithm affects them, and they can't just turn it off or opt out. So I just wanted to, clarify that as a sort of immediate understanding of, we often work in contexts where that option of opting out is not there. The sort of second assumption is that I think sometimes when people hear AI or machine learning or even robotics, they'll think of something super sci-fi. They have an image of something that's very intelligent and very complex. In reality, these systems are very, very simple. I sort of mention, I compare them to Roombas. So my background's in robotics, and often when I tell people I'm working on robotics, they think of Sophia the robot, which is this humanoid machine. Looks very real, it looks very complicated, but in reality, the sort of most widely deployed robot in the United States at the moment is the Roomba, and that's in millions of homes. It's highly influential as a robotic device, but it's also very simple. It's not necessarily super complicated, but that doesn't make it less impactful. So that's really a lot of how these real world algorithms work. They're often quite simple. They're not very technically complicated, and they're deployed at scale to the order of hundreds of thousands of millions of people impacted. And an example of this is, the Stanford vaccination algorithm I had mentioned earlier was revealed to just be, a set of like embedded if statements, pretty much just a set of declared conditions. It's very simple as an algorithm itself, even though it was definitely consequential on the lives of those that were impacted. So the real world is full of Roombas, and often nothing more complicated than that. And then the sort of final reminder is that at least the work that the Algorithmic Justice League is involved in, we're looking at impact, in the real world most of the time. So impact does exist outside of the imagination. I think, again, people, have a vision of certain threats, and they speak about certain threats in a very hypothetical or rhetorical manner. But in reality, there's a lot of real people being impacted by these deployments. So we need to consider and reflect on real outcomes to these real people. So now that we have those reminders out of the way, I'm going to go into what I mean by algorithmic accountability, and then we're going to focus on engineering responsibility and what we try to do in order to address that challenge of engineering responsibility. And then I'm going to go into the other challenges I had mentioned earlier around operator accountability and structural harms. So let's go into what algorithmic accountability means. So algorithmic accountability is, and this is a great paper that I'd encourage anyone interested in this topic to read. It's a survey paper by Waranga at the FACT conference last year. And she pretty much surveyed, hundreds of papers discussing this concept of accountability as it applies to the algorithmic, an algorithmic object or an algorithmic device. And she frames it as, this relationship between an actor and a forum, where the actor is the stakeholder that has agency in the situation, that can change the situation, and the forum is the stakeholder that's impacted by the situation. So the forum can sort of demand information from this actor in order to, cast a judgment on the stakeholder that has agency to change the situation, and then impose certain consequences in order to improve their situation. So, those are a lot of words, but what it pretty much means is that there's a lot of involved stakeholders, and you pretty much have someone that's responsible and someone that's judging that person that's responsible in order to demand consequences if that person isn't living up to their responsibility. So with machine learning, AI, algorithms, there's a lot of different stakeholders. There's governments, there's policymakers, there's product developers and technologists, there's data subjects, operators, advocacy groups. Several of these stakeholders can actually determine a model's capacity to do harm. If we want different outcomes from that model's impact on a situation, who needs to take action and who needs to face consequences. So I'm going to start by talking about, one challenge to sort of accountability, or one issue that we face often, which is this challenge of engineering responsibility. So engineering responsibility is really this situation where, we're asking the question of, well, how do we hold those that are building these tools in a way that hurts people accountable? So if they're building these tools in a way that's harmful, how do we hold those people accountable? And it's really not a new idea. So, to the left, you have the Quebec Bridge. I don't know if there's any engineers in the audience, but the Quebec Bridge is a very common example or classical example of what engineering responsibility means. In 1906, the Quebec Bridge collapsed due to sort of the inattentive oversight of the lead engineer, Theodore Cooper. And when the bridge collapsed, about 75 construction workers working on the bridge that day died. And in the actual official report, sort of the postmortem of that collapse, they named Theodore Cooper, the lead engineer on the project, as one of the causes for the collapse, because he had received a bunch of warnings, he had made a bunch of mistakes, and it was one of the sort of first sort of landmark cases to highlight the responsibility that every engineer has to do their own due diligence when they're building these structures, these artifacts that impact people or have the potential to impact people or hurt people. So that's a very classic example of engineering responsibility. And then, decades later in the 1960s, Ralph Nader wrote a great book called Unsafe at Any Speed, where he talks about this car over here called the Chevrolet Couvert. And he talks about how the engineers that worked on the car cut a lot of corners due to time pressure, due to design choices. And as a result, the car, which is the sports car, had a lot of steering difficulties. It was really difficult to control the car when you try to steer it around corners, especially at high speeds. And that was genuinely a safety risk that ended up putting a lot of drivers at risk. And in his book, he talks about that as a lack of engineering responsibility. And he kind of reaffirms or reiterates the importance of those that build the systems that we use, being attentive to their own responsibility to make sure that those systems work in a way that doesn't harm people. Decades after that, we're sort of seeing a similar pattern in terms of the need for engineering responsibility in this age of artificial intelligence or AI or algorithms. So an example I often point to is Michigan's MIDAS unemployment system, where this was an algorithm that was meant to automatically identify and flag applications for unemployment insurance that could be potential fraud cases. And the algorithm sort of falsely accused more than 34,000 unemployed people of unemployment insurance fraud. And as you can imagine, that caused a lot of strife for those individuals. It caused a lot of inconvenience. They also could not receive unemployment benefits for that period of time. And an investigation into the actual algorithm itself identified the sort of key failures to be a lack of, migrating the data from a legacy system into the database that was used to train the algorithm. So it was as simple as, them not being cautious enough when they pulled data from the legacy system. They had missed data points. They had, put in wrong numbers, just very simple mistakes that really should not have happened for something as important as this particular application. So, clear lack of sort of conscious decision-making and careful decision-making considerations when building these systems. And that demonstrates a lack of understanding of their responsibility as the engineers of that system. And then we sort of saw this theme come up again with the Uber crashes. The NTSB report for Uber's test for the self-driving cars, when it had sort of resulted in a fatal crash of the pedestrian that was crossing the street, that was jaywalking across the street. The NTSB report also names engineering responsibility as one of the the failures of the development of these systems, where for one thing, the developers of the computer vision system that was meant to help navigate the car hadn't identified the jaywalking pedestrian. But on the other hand as well, those developing the system or designing the system hadn't address the fact that the test driver could be distracted in various ways, and having particular mechanisms to keep them alert, hands on the wheel, eyes facing forward. So there were definitely some failures in the design and the implementation of this particular product, and that made it more harmful and sort of put those that are affected at greater risk. So, what happens when someone builds something, an AI tool or an AI product that sort of puts people at risk by virtue of just not being very robustly or considerately built? So we have sort of three strategies that we try to do or think about. So one is auditing, the other one's regulation, and the last one is recall. So, what can we do if someone built something that could potentially hurt people? Well, we can audit that thing, we can audit that product. And there's sort of two forms of auditing. One is this idea of an internal audit, which is, a set of employees of the company, or not necessarily direct employees, but people paid by the company to come into the company to assess the quality of the product development process itself. So this is, IBM, Google, Microsoft's responsible innovation teams, perhaps an external consultancy like Accenture that's hired into the company, or Orca, which is sort of another consultancy that might be pulled into the company. And an internal auditor has full access to the system. They're looking and analyzing the system, usually pre-deployment. It's executed by employees, and there's a focus on compliance and quality control. They're trying to make sure that the product is as good as it can be before it gets released into the world. External auditors are regulators like the National Institute of Standards and Technology, or the FDA. It's like investigative journalist groups like the Markup, or investigative agencies like the Government Accountability Office, or it's advocacy groups like AJL or ACLU or Upturn. And as external auditors, we do not have direct access to the system. So usually consumer level access to the system, looking at the system post-deployment, but as this independent third party with a focus on representing the interests of very particular groups. So, when you're auditing from the outside, it's not necessarily something new. So external audits is something that's been happening for quite a while. There's already been quite a few papers for a while discussing this phenomenon, or this idea of looking from the outside in order to be able to assess or evaluate a system externally. And here's a couple of papers from the last couple of years on that issue, even with facial recognition. However, there were sort of these consistent challenges when you audit from the outside. So for one thing, there were biases in the benchmarks and the evaluation test sets that were being used for these external audits. There was issues with accessing the target. Like I mentioned earlier, you're from the outside, so it's very difficult to figure out exactly what you're auditing and then identify that to be able to isolate that in an audit. Public pressure, usually people would release an audit study and not be able to garner the attention of either the press or the public or the actual company they're auditing. And then finally, there's sort of this threat of a hostile corporate reaction. So once you release an external audit as an outsider, without the company's cooperation, it's very possible the company will get very mad at you and try to sue you. And in our paper, Actionable Auditing, we kind of talk about these three different challenges, and we talk about, approaching this project that we had worked on called Gender Shades with this question of, well, how can we design algorithmic audits to address these challenges and actually get companies to change or to mitigate our bias concerns? So we looked at a bunch of other different communities, and we try to address each of these challenges, looking at these different communities as inspiration for design choices in the way that we implemented the Gender Shades audit. So we looked at anti-discrimination law and what they had learned from this concept of intersectionality to really help us with an intentional design of a benchmark to address the bias issues around the testing process. We looked at the HCI community and a lot of the work that had been done on online platform audits to think about how to really isolate a target for the audit. We looked at the financial auditing industry to figure out how to incite public pressure on targets once they're being audited. And the financial industry has a really great strategy of publicly naming multiple targets. And then for hostile corporate reactions, we looked at the information security community where, to demonstrate vulnerabilities in different software systems, they have a lot of very thorough disclosure policies. And we realized we could adapt some of those disclosure policies for our algorithmic audits in order to minimize the hostile corporate reactions. So we were pretty much doing all of this to get to design and implement an audit that would get the companies to actually be accountable and to feel the consequences that we wanted them to feel. So one of the big primary contributions was this development of the Ppb benchmark, the pilot parliaments benchmark, and to sort of compare that benchmark or that test set to the other mainstream FACE data set benchmarks at the time. You can see that PPB is much more balanced with respect to male-female representation and darker and lighter skin representation than all these other mainstream benchmarks, which are up to 77% male, up to 94% lighter skinned. And we're about 50-50. And the result of the initial gender shades audit was on Microsoft, Face++, and IBM's facial analysis product for gender classification, was that the products completely underperformed for darker female faces. So you can see here that these products are performing at less than 80% for darker female faces, and closer to 100% for every other demographic subgroup. So after we released this result, implementing some of the design decisions that we had made for the audit itself, we were getting all of these responses. So we were getting responses from different companies that we had audited and companies that we hadn't audited, like Kairos, mentioning how the audit had inspired them to make improvements or to make updates to their actual product itself. So we decided a year later to revisit the products that we had initially audited, and in addition to other products in that market, to see how the audit had actually hopefully influenced the practices at these companies and the actual sort of quality of the product, or the ability of the product to have the disparate performance that we were worried about initially. And what we found was that, with, this is Microsoft as an example, but with a lot of the with all three target companies, about within 7 months, they had re-released they updated their product, and their product performed significantly better, specifically for the darker female subgroup. So you can see the difference here between 2017 and 2019 for Microsoft. A lot of the improvement or a lot of the update in performance happened for this darker female subgroup. Performance went from 79% around to over 98%. Same thing with Face++, which is another audit target, from about 65% performance on this darker female subgroup to 95% performance after it was audited. And then here you see IBM had made the update from 65% accuracy to 83%. And what that really allowed us, what those results allowed us, was the ability to counteract comments like this. So prior to gender shades, whenever a product did not work for darker skinned individuals, the result would sort of prompt a comment such as this, which is, oh, it's just harder to take a good picture of a person with darker skin than it is for whiter skin. There's something about darker skinned individuals that make it just a fundamentally harder problem. All three of the audited companies a year later were able to make updates that drastically improved performance for the darker female subgroup. So it provides evidence for you to really counteract excuses like this. And that's one of the values of the sort of audit strategy in general as a mechanism of accountability. You have hard evidence to really hold companies accountable when they fail on particular populations. And the sort of interesting thing about the actionable auditing study as well is that we audited Amazon and Kairos in 2018 as well. And Amazon and Kairos were not included in the initial gender shade study, but they're sort of part of the same market with very similar products. So we were able to audit them, and we demonstrated that these companies, although they were in the same market and aware of the same issues and they had very similar products, did not sort of perform at the same level as the companies that we had previously audited. So Amazon and Kairos were still sort of performing at a very sort of subpar level for the darker female subgroup compared to performance on the lighter male subgroup. And aside from demonstrating that there was definitely an industry-wide issue, there was also definitely a lot of insight following our actionable auditing study into how this issue was not just specific to gender classification as a task, but also other facial analysis and facial recognition tasks. So here is a study that was done by NIST shortly after the publication of our paper, and they sort of cite our work and talk about the need to evaluate performance on these different demographic subgroups and audit performance on these different demographic subgroups. And they find that Asian and African American people were up to 100 times more likely to be misidentified than white men. And this is a completely different task. This is for face identification, which is this one-to-N matching and face verification task. So it's not even a classification problem, and we still saw similar problems once we audited for them. And then at the same time, there was also this rise in pilot studies that happened at around the same time as well, where in response to this investigation of the functionality of facial recognition, a lot of people were taking that facial recognition tool and testing it in the wild and seeing how well it performed in the wild. And a lot of the pilot studies revealed that there were huge functionality issues with this technology in the wild. A great sort of pilot audit done by Big Brother UK, which is a advocacy group, a privacy advocacy group in the UK. They found that UK's police facial recognition system had an 81% error rate, meaning it was correct maybe 20% of the time once deployed in the wild or tested in the wild. And the MTA in New York, they had a pilot study for their facial recognition product that they wanted to use for highway monitoring, and their pilot revealed that the product was correct 0% of the time. So every single time it failed. They actually, for that particular pilot, they actually continued to try to use the product, which is something I still don't understand. But pretty much it was prompting this questioning of, how functional are these technologies? And people were doing a lot of interesting follow-up studies to reproduce our results, and then also investigate the performance of these systems in the wild. So, one of the challenges of auditing as a mechanism of accountability, for concerns around engineering responsibility is that, once we audit a company, they try to make sure you can never audit them again. So this is Kairos, one of our audit targets in 2018 for the actionable auditing study. And you can see that their minimum plan is $99 a month. So they used to have a free premium plan, which is how we were able to audit them. But their minimum, sort of their cheapest plan, they sort of raised, they put up this paywall to prevent people from being able to casually audit their product, their API. And not only did they do that, but if you sort of click through everything, before you can make that purchase, you have to click onto a terms of service where there's a clause in there about not allowing you to use their product for purely auditing purposes. So there's a lot of barriers that these companies will pull up once they realize that they're potential targets for an audit. Another sort of drawback of the audit approach is that the corporate responses are not always appropriate or adequate. So, once you audit a company, they can respond in various ways, and not all those ways are necessarily aligned with the values or with the response that you're hoping for. So once we audited at IBM, they released this diversity in faces data set where they perceived the issue to be the fact that they were underperforming on particular demographics because they were underrepresented in the data. So they said, well, let's build, a large face data set of diverse faces, and we're going to use that to sort of combat this challenge of underperformance on underrepresented groups. The challenge, the sort of drawback of that was that they had sourced their faces from Flickr, and there wasn't necessarily any sort of clear articulation of consent or privacy protection as part of that process. So a bunch of Flickr users whose content was included in that data set got a bit upset, realizing that their faces were being used as part of this facial recognition training set. And there was a lot of sort of blowback to IBM for that reason. And then similarly, our audit of Face++ prompted a discussion about, the quality of performance on different demographic groups for facial recognition products from China. And another Chinese company, CloudWalk, actually purchased darker skinned faces, the face data of darker skinned individuals from the Zimbabwe government in order to diversify their data set. So, there's a lot of really crazy scenarios as to people exploiting, particular underrepresented populations, lacking consent and privacy and engaging in tokenization in order to diversify their data set. And that's definitely not the kind of response that we wanted to our audit. The other thing about an audit, or limitation of an audit, is that you only have a very sort of narrow scope of impact. So you can only really rely on targeting a very specific demographic group, a very specific prediction task, and a very specific company. This is a graphic from one of our papers called Saving Face. And we talk about sort of, post actionable auditing and gender shades. We were seeing, people attempting to make use of a Ppb-like benchmark as, the litmus test for, whether or not a product should be deployed, and integrating that kind of litmus test in policy. And we were, not for that, because we understood that, and we sort of reevaluated Microsoft's product, Amazon's product, and another product from a company called Clarify, and we were able to show that, yes, we already know that Clarify, as a company that had not been audited before, still has these disparities for gender classification that Microsoft and Amazon don't, by virtue of them already being audited for that task. But if you look at another task like age classification, Microsoft still has those disparities for age classification, and Amazon definitely still has those disparities. So, the audit impact was so specific to the particular task and the particular company and the particular demographic group as well. If you look at Ppb, it's not balanced with respect to age, for example. So, you can't use Ppb to audit for disparities with respect to age. So there's always going to be some element of the data set that it's biased towards or biased against. And it's really important to be very clear about what particular demographic you're auditing for and what the data set actually represents. And then another sort of final limitation of auditing is that, especially with facial recognition, you have a lot of people making claims about what they can do with facial recognition, using it to detect, criminality and hireability, character, sort of personality traits. And there's no, an audit isn't going to necessarily be able to discredit those pseudoscientific claims. And that was a limitation that we saw, where there's no point in auditing, a product that's attempting to use facial recognition to detect criminality, because the whole sort of premise or objective of that is flawed. So that was another sort of challenge or limitation of these audits, is it doesn't necessarily address these pseudoscientific claims, and it doesn't discredit work at that level. So outside of external audits, another sort of strategy for accountability is this idea of internal audits, so auditing from the inside. And here's a sort of diagram of a very common paradigm that people talk about with auditing, which is this idea of the 3 lines of defense. So within a company, you sort of have, 3 opportunities to really protect yourself against, regulatory restrictions and regulatory obligations, or external audit requirements. And, the 3rd line of defense is this internal audit, which is this internally independent group that has, oversight or a view into what's happening throughout the entire process. It can really make an assertion as to whether or not the product is ready for deployment, or up to par with the expectations of an external auditor or regulator. And the current strategy for internal auditing right now with machine learning is this idea of transparency and communication. So this started off with this idea of communicating through data documentation, really writing down the details of a data set. And here's a couple papers that were sort of the initial proposals for that. And then it evolved into, we should actually just also be writing a lot of information about the model and communicating about the model's capacity itself. So this was a huge project that I worked on with collaborators at Google, and it's this idea of model cards for model reporting, where as a form of internal accountability, you actually record information about the model and use that as a mechanism to communicate internally and to hold yourselves accountable to a particular standard of performance internally. So it includes like overview, details about the model itself, an articulation of use cases and limitations and ethical considerations, but also it kind of pushes engineers to go through these evaluations of looking at performance across different demographic groups, and looking at performance from different angles and from different perspectives of concern. So yeah, for example, this is the first model card that was released by Google. It was from the Perspective API team, and they have a model that will filter out toxic content. And what they did was they had multiple versions of their model card. So to the left, you actually have their performance metrics from their first model card, where it's clear that they're sort of disproportionately flagging terms that include particular identity terms. So Black gay or Black queer as particularly toxic. And then to the or to my right, you have the sort of sixth iteration of that model from their sixth model card, and it shows that they've actually taken steps to address that issue significantly over time. So it was just a way to communicate externally and internally about the details of the model and the progress of the model from version to version. And since then, there's been a lot of actually support for model cards at Google. They've developed a lot of resources to help accelerate the development of these model cards. Here's an example of the model card toolkit that was released quite recently. And in addition to that, in addition to this, the documentation around data and documentation of the model cards and AI principles and product requirements documents, this idea of internal auditing is quite common in very high stakes sort of engineering context. So in finance and aerospace and healthcare, there's a very sort of robust culture of internal auditing and sort of internal checking and internal accountability. So there's a lot of other documents that we don't really make use of in machine learning that are definitely worth adapting to the algorithmic sort of context or algorithmic case. So here's an example of, we had written a paper where we identified a bunch of different templates from all these different communities that we could definitely see adapting or being useful for the algorithmic development process. An example of one of the documents that we identified was this idea of a FIMIA, where you look at a particular feature and you identify user action and interaction with that feature and the intended response and potential failure modes and potential consequences from those failures and how visible those failures are and how serious those failures are. And it's just another tool that we don't necessarily, these are all questions that we don't necessarily ask ourselves about, machine learning models as we develop them today. So looking at these documents from other communities, FIMIAs from the aerospace community, kind of could potentially prompt the machine learning community to really start thinking about some of these situations a little bit more carefully. And we'd actually sort of place these different documents within a broader internal audit framework. So people that are interested in that should definitely check out this paper where we talk about how these different additional documents can really enrich our understanding of what an internal audit process could look like for machine learning or for algorithmic development. And then in addition to that, another sort of additional effort around internal accountability has been the About ML project, where it's through the partnership on AI, which is, involves Google and Microsoft and all these big tech companies, in addition to sort of civil society orgs like the ACLU, where they come together and they try to come up with best practices for the field around, accountability mechanisms. And one of them was really around benchmarking and transparency and thinking about documentation. So the About ML project really pulls together a bunch of different documentation efforts from Google, from Microsoft, from IBM, and tries to consolidate that into a set of requirements for best practices. So unfortunately, the downside of internal auditing is that there's limitations to what an internal auditor can actually do. As an employee of the system, the internal auditor can only really voice concerns up to a certain degree. Once there's enough conflict, the internal auditor can definitely be pushed out. So that's what I believe happened to Timnit, where Timnit was the lead of the ethical AI team at Google, very outspoken about particular risks, in this case about risks with respect to large language models. And just by virtue of being an employee at the company and raising those risks, if those risks were incompatible with sort of the product direction or the intent of the company's leadership, then it's sort of very easy for them to just push her out and avoid that accountability. The other sort of drawback of internal auditing as the mechanism of accountability is that models are quite complicated and bias appears in multiple different points. So just because you have full access to the system doesn't actually make things easier. It kind of makes things difficult in a particular way where you can, you now have to think about so many more things. And that's exactly what happens with internal auditing, where you have to consider bias as it appears in all these different points in the development process, and things just actually become a lot more complicated. So that's definitely another sort of drawback to internal auditing, is that the complexity of the situation and the audit itself is greatly increased just by virtue of the amount of access you have and the kind of questions you're asking. So, we can try to audit systems that we think are sort of irresponsibly built, but another strategy is just, direct regulation. And that's what happened with facial recognition to some extent as well. Much more last summer, but even until now, we have this sort of wide sort of, I guess, a trend happening where there's been a lot of interest in facial recognition regulation and just restricting the use of the technology through different ordinances, municipal ordinances or statewide and some national level sort of proposals for, restricting the use of the technology and also mandating the sort of assessment and quality assurance of that technology. So if it's not responsibly built by those that are building it, we can regulate it into sort of submission and make sure that the products that are deployed are sort of regulated in a way that doesn't hurt people. And while we were doing our work with gender shades and actionable auditing, ACLU was also sort of running a campaign against police use of facial recognition and restricting that. So we actually had a lot of interesting partnerships happen, due to their work as well. So a lot of the regulatory effort was really led by the ACLU in a lot of ways. And after every audit, we would get a bunch of these responses from the companies, either in the press or on their corporate blogs, mentioning the need for facial recognition regulation. So after we would release the audit demonstrating these the particular failures that we had highlighted, we would get a bunch of responses from Amazon. Here's a specific thoughts from Amazon and Microsoft in particular, saying like, yes, this demonstrates that there's particular failures to this technology and we need to have regulation to make sure that it's being used responsibly. But the sort of downside of relying on regulation as the mechanism of accountability is that in reality, the regulatory process is actually quite complex and not necessarily as reliable as people assume. So, for one thing, companies actually have a huge influence on Congress. It's a little bit hard to see, but this is a sort of to the right, there is a bill profile for the Commercial Facial Recognition Privacy Act of 2019. And you can see that there's sort of 2 Amazon lobbyists on that bill. For every facial recognition related bill in Congress at the moment, there's at least 2 or 3 Amazon lobbyists on that bill. And Amazon paid a lot of money to sort of prevent the facial recognition ban in Portland. There's also the fact that a lot of legislators have connections to big tech. So Kamala Harris, who's now vice president, but at the time that a lot of these bills were being drafted, she was senator in California. And a lot of her senior staff members, so I remember talking to an Amazon lobbyist that had previously been a senior staff member for Kamala Harris. So he had sort of been on the committee drafting the facial recognition bill he was now lobbying on. So that happens all the time with regulation. So it's not necessarily great to rely on it as a mechanism of accountability for these companies. The other thing as well is these companies sort of leverage a lot of their power to influence shareholders in particular ways. I can't get into the particular details of this case, but Amazon definitely does that a lot, where they campaign on shareholder votes to get a particular outcome in their favor. So, for that reason alone, we can't always depend on regulation as the mechanism for accountability and for counteracting, lapses of engineering responsibility. So the sort of third strategy we have is this idea of a recall. So a recall is this idea of retrieving defective or potentially unsafe goods from customers. So it's saying, you've deployed a product that's harmful, either voluntarily or in a mandatory fashion, we demand that that product, by virtue of its defects and its potentially unsafe status, gets pulled from the market. So, once we realize that a product is, incredibly unsafe, it's actually not suitable to be on the market anymore. And it ranges from an outright ban to self-return, very common with, if you can think of recalls for cars, a lot of consumer products are sort of liable to recall. It's very common for food. But the idea of that happening for algorithmic systems and for AI products is a very new idea. And it kind of did happen with the facial recognition case. So over the summer, June 2020, with the rise of the George Floyd and Black Lives Matter protests, there was renewed pressure on the tech companies we had audited, so IBM, Amazon, and Microsoft in particular, to halt the sale of facial recognition, in particular to police, but also just pull out of the market completely. And the narrative shifted from, these products are really harmful and they don't quite work. They should be regulated, to, oh wait, they're harmful and they don't work, they shouldn't be on the market at all. While the regulatory conversations are happening and the regulatory negotiations are happening, we should completely pull these products off the market. So we actually saw that recall happen. IBM itself claimed to pull itself out of the market completely. Amazon put a one-year moratorium, and Microsoft sort of made a vague statement about pausing sale to police. But the challenges with the recall is that it takes a long time. It took 2 years of advocacy to go from we have these flawed and racially biased technologies to the companies agreeing to pull the products off of the market. The other thing about recalls is that there's loopholes. With a lot of recalls, Amazon sort of claimed, we're going to pull our facial recognition product off of the market for a year, and they're still sort of partnering with 400 police forces through their Ring product and their facial recognition capabilities through their Ring product. There's all these loopholes that might exist with a recall, and that's been a problem. That's a problem in the auto industry, and it's a problem. It'll probably be a problem. It's an anticipated problem for the algorithmic context as well. So very quickly, because I'm looking at the time, I'm just going to go through some of these other challenges. So what we talked about was pretty much, when people build things that hurt people, if the person that built the algorithm, it builds it in the shoddy way, how do we actually hold them accountable for the lack of engineering responsibility? It's not, those aren't the only stakeholders to be held accountable. There's also the stakeholders making use of the algorithm that need to be held accountable. There's also, those sort of propping up historical legacies and norms of society at large that need to be held accountable. So there's, in addition to engineering responsibility, we also think a lot about this idea of operator accountability and structural harms. And I'm going to go through this as quickly as I can. But pretty much the analogy that I use here is, that of cars. I think what happened with the auto industry is a very good analogy where, cars cause a lot of pollution. They're really bad for the environment. They flatten cities with roads. There's a lot of structural issues that arise from the introduction of cars. And that is, one of the structural harm challenges that we need to address and we need to fight for, and we need to advocate against. On the other hand, you also have, certain cars that are just poorly built, cars with brakes that don't work, cars like the Chevrolet, like the Corvair that Ralph Nader was advocating against, where the steering doesn't work. These poorly built cars are constructed in a way that causes harm or that increases the probability of harm. And those cars should not be on the market. And then we also have issues of operator accountability, where the car is perfectly, it's built well enough, but the driver itself is acting irresponsibly or acting in a way that can cause harm. So you might think of like a drunk driver, for example, could be an unaccountable operator. So we see all of these situations happening with algorithms as well, that dynamic of, you having some shoddily built algorithms and also having some algorithms that are misused, and then also dealing with these sort of structural harms and structural consequences due to the introduction of the algorithms themselves. So I'm going to go over this very quickly, but the challenge of operator accountability is pretty much those that make use of these tools irresponsibly. I'll just give a couple examples of, facial recognition tools where you might use a sketch as the input when it's meant to be a photo input. And that happens with a lot of facial recognition tools and police use of facial recognition tools. There's a great article called Garbage In, Garbage Out, where they talk about all the ways that police departments, they don't set thresholds, they use the wrong types of inputs, and that causes a lot of harm. The other thing as well is that you can have these products, be misused and abused and weaponized. A landlord weaponizing facial recognition against their tenants, police use definitely being weaponized against minority communities. And even this paper on, the weaponization of facial recognition to target minorities, in different capacities. So there's all these ways that it can be actively misused and abused. And the challenge with operator accountability, or one of the big challenges with operator accountability, is the lack of disclosure. So New York City actually had to pass the Post Act that required police to reveal or to publicly disclose the surveillance technologies that they were making use of. Because in New York, you have all of these surveillance cameras no one's aware of, and they're recording information about people that can be analyzed. And here, there's a great article in the New York Times where they access this data and they're able to actually correctly identify individuals as they walk by through the park. So the lack of disclosure is a huge issue with operator accountability, where some of the operators will make use of these algorithms and not even disclose that to the public that's impacted by it. And then this issue of structural harms is just society not being built to protect the vulnerable. I can't go into the details of it, but it's pretty much this idea of the data that we have available on the internet just being, by default, due to media bias, just, complete distortion of reality. And there's a great paper by Abeba on these large image data sets and how, by virtue of just their scale, it introduces all of this, this sort of very, inflammatory, horrible content. And it's almost inevitable by virtue of just the inability of us to curate these large data sets that we feed into our models. At the same time, legal structures are not very compatible with algorithmic accountability. There's a lot of particular characteristics of the legal context that is kind of incompatible with holding an algorithmic tool to account in a way that we would expect, a human making the same decisions to be held to account. And that makes things really, really difficult. I will go through this very quickly, but pretty much the other thing as well is that there's a lot of anti-hacking laws from the early 2000s that also prevent auditing work from happening and causes a lot of difficulties for auditors as well. And investigative journalists also kind of fall into the same boat. The CFAA is sort of the main anti-hacking law where, breaching a company's terms of service as described, even for the analysis of that product for the sake of accountability, ends up sort of putting you on the wrong side of the law and putting you at legal risk. And that's definitely a way that sort of society itself kind of is structured against the accountability of these systems. And then finally, society is not necessarily one that has a lot of options for victim compensation or protection. A lot of people outside of our space have no idea of what's going on with these algorithms, have no idea that an algorithm is involved in a situation in which they're treated unfairly. And even when they do realize that they've been treated unfairly, they don't have a lot of avenues to get legal protection and to seek compensation. So, for me, the thing to remember, and this is something that becomes clear even from the earliest examples of engineering responsibility with the Quebec Bridge, is that, of the 75 individuals that died that day, about 55 of them were sort of part of the local Native American population who were already quite underpaid and mistreated in Canadian society at that point. And it kind of reveals that even at that time, when you have these structures that fail or these lapses of judgment or attention or caution, those that are most impacted are those the least privileged, the least protected in society. And that's exactly what we see with these algorithms today. A lot of those impacted by these AI deployments are young people, elderly, those with disabilities, people of color, low-income individuals. There's a lot of, it's very clear who these systems are going to be impacting at the end of the day and who is going to get hurt. So yeah, if machine learning doesn't work for everyone, it doesn't work at all. And we actually truly have an obligation to hold these, institutions and operators and society itself accountable for all the ways in which it fails that population that gets hurt. Thank you.
Thank you so much, Deb. I think there's just a wealth of information there. I took so many notes. I have like pages and pages of notes and papers that I want to review after that talk. So just thank you so much. We have a couple of minutes for talks. Or for questions. Sorry, I want to respect Deb's time and everybody's time, but I'll open the floor for questions. Feel free to use oh, we have somebody jumped here. Daniel?
Hi, Deb. Thank you for the talk. So something I've been thinking about recently is Amazon's 1-year ban on facial recognition is coming up. What are your thoughts on what they're gonna do, kind of in light of their previous stances in the past on the technology?
Yeah, so I'm not optimistic about them having like a actual long-term ban. The new Amazon CEO has already gone on record to sort of defend facial recognition in a couple interviews. So it's clear that they see enough market potential that they're not going to sort of back down from their stance of releasing the technology. I also know that for the year that they banned the technology, that they had sort of restricted their use of the technology, they've sent like an army of lobbyists on every single bill. So I think for the last year, they've sort of been more focused than ever on influencing regulation on facial recognition, which I find to be really concerning. I think that our strategy right now is to sort of put enough public pressure on them to not be able to do that. So a lot of that means like sort of counteracting that lobbying with sort of our own proposals for how these policies should play out, and Joy especially has been very involved in that. But on the other hand as well, not over relying on voluntary recall, but actually making it mandatory in some capacity where they're not able to release their product, under specific conditions or until certain concerns are addressed. And right now, it doesn't seem like any of these companies are even coming close to addressing the concerns raised by advocates around the technology. So hopefully that can be a strategy moving forward. But yeah, we're hoping that we rely less on this mandatory, so this voluntary recall kind of phase we're in, and move towards a more mandatory recall phase.
Thanks, Deb. CD?
Hi, Deb. Thanks for the talk. Really interesting. I think there's a interesting sort of gray space between where you decide an algorithm is non-functional versus like kind of like broken. I think like the car examples versus an algorithm is biased, which is, I think, are two different things that sort of deserve further attention. But I'm curious, given that we live in a structurally biased society and all of the algorithms that we use sort of take their data from a society that is structurally biased, do you anticipate that it's ever actually possible to debias algorithms that we use to sort of that sort of by necessity need to ingest large amounts of data in order to learn, in order to train? And if they're coming from a biased pool, how do you actually create an algorithm that isn't biased?
Yeah, so also to clarify, like with respect to that analogy of a car breaking down in like a biased algorithm, I think it comes from the place too of there's a difference between an algorithm that sort of represents a particular worldview, and that worldview not being clarified, versus an algorithm that operates in a context outside of what it's been trained to operate into. So if the product does not work for a particular population, it shouldn't be deployed on that population. And I think that that's a lot of the cases that we're seeing with these systems where they're deployed for a particular context, and then or they're sort of developed for a particular context and then deployed outside of the appropriate scope of what they've been developed for. So I think that those are the situations we're sort of raising the alarm about, situations where you're training a model on faces from a particular demographic and then attempting to deploy it outside of that scope in a way that the failures can really harm the population outside of the scope. So yeah, with respect to, can we debias or have this unbiased data set? I don't think so. And I don't think anyone is necessarily advocating for that. A lot of these, like I mentioned earlier, even, the Ppb benchmark that we develop, it's great for auditing for, skin type and gender expression. It's not great for auditing for age, because you're going to have some dimension in which you're biased towards or you're biased against. Your data is anchored to a particular perspective or lens. There's just a couple of things around, the responsible management of that situation. So one being communication. Like if your model is if your data is, is curated from a particular context or sourced from a particular context, communicate that to the end user or to the developer user for your model, so that they don't deploy it outside of that context that it's meant to be, to be used in, and thus sort of inadvertently fail on individuals that are outside of that context. So communication is actually a huge sort of step that I don't think the field has really taken yet around. Here's the limitations and here's the scope of performance for my model. Outside of this, my model isn't going to be helpful. So that's one thing. And then the second thing being, being very cautious of, situations where, if you know that the technology is going to be used on a particular demographic, ensuring that it doesn't disproportionately fail for any element of that demographic that you really care about. So, if I know that my product is meant to be used in this particular context for this particular demographic, my model should be at minimum tested for performance on that demographic. So those kind of intentional questions, or just having intentionality around reflecting on diversity in the data sets being used to develop and test the models, is sort of the step zero that we're advocating for.
Awesome, thank you.
Deb, we had a question come through the chat from Lisa. What is the best way for non-engineers to influence any of the systems of accountability you mentioned?
Yeah, I think there's a lot of ways for non-engineers to influence the system. I definitely think that there's a lot of opportunity for those in an advocacy role to really support thinking around regulation and thinking around how to particularly campaign for recalls. There's been a lot of the movement that we've seen with respect to people actually pulling harmful deployments off the market. Another example I didn't mention was the Stanford vaccine algorithm that I had sort of mentioned earlier on. Due to the sort of protesting of the residents, they actually did not use that algorithm anymore. They sort of pulled it out or recalled the use of the algorithm, and sort of installed a manual process instead. So all of these situations, all of these wins are sort of due to a lot of advocacy, and that requires a completely different set of skills around campaigning, around building solidarity, community building, and those are not necessarily like technical skills or technical auditing skills. The other thing as well is that some of the internal accountability work actually requires a lot of interdisciplinary thinking. So a lot of the efforts around documentation, some of it is, around like evaluation and technical evaluation, but some of it is also just really reflecting on, potential risks and potential failures, and doing that in a way that's quite interdisciplinary. So a lot of these internal audit teams at these tech companies, but also some of these consultancies, they have quite interdisciplinary teams where they'll have a lawyer to think through some of the privacy concerns, and they'll have people with different skills to just ask different questions about the model and raise different concerns. So there's a lot that can happen, without knowing how to code or something.
Thank you so much, Deb. I realize now that we're almost at 10 after, and I do want to respect everybody's time. Just thank you so much for being here. If everybody could give Deb a huge round of applause. And also a big thank you to our RISE ASL interpreter, Amy. Thank you, Amy. I will hang out here just for a little bit if there's anybody who wants to hang or any students who have questions. But thank you all and have a wonderful rest of your night.